This is a mostly 8-7 lesson, although this first thing is the end of 8-6, but it's quick, so, and it's easy. Take a look at 18x squared minus 33x plus 12, and I want you to realize that every term in here has one common factor, and that factor is 3. So before you do everything else that you're going to do to this, factor out the 3. So it becomes 6x squared minus 11x plus 4, and then you're going to factor this with the regular process. So what are factors of 24, which I get from multiplying 6 times 4, that add up to negative 11, negative 8, and negative 3. So now you are factoring this. Zoom in a little bit. There we go. Now I'm going to go to 2 sets of brackets just to make this really, really clear. Yeah, I switched my order because it wasn't going to work the first way. So you see this different looking set to make it very clear that the 3 is outside of this whole thing and the regular parentheses inside. And then we end up with this, but now the second set of brackets is redundant, so I rewrote it that way. Okay? Now we're truly on to 8-7, and really this is kind of a shortcut lesson, which means you don't have to do it this way. It will save you some time if you do. Remember the work we did not too long ago with a plus b quantity squared and a minus b quantity squared? Well, now remember we're going backwards, we're factoring. So if the first and last terms of your polynomial are squares and the middle term, remember we had that 2ab nonsense, then your polynomial will factor into either a plus b quantity squared or a minus b quantity squared. Let's go through this a few times. Now I have jumped to page 512. I'm looking at problem 1a. So the first thing you need to check, is this term a perfect square? Yes, it is. Is that term a perfect square? Yes, it is. Does this middle term fit our 2 times? All right, so I'm experimenting with voiceover because I was very unhappy with my first explanation of this. I want you to think about the square root of your a term, which is 1, and the square root of your c term, which is 3. 2 times 1 times 3 gives you that 6. That's what is your second check to make sure that this will factor in the proper format. Once you've checked that, then you know it'll be x plus 3 quantity squared. That's better. I have a sneaky suspicion that the best way to show you guys this will be just to work through it with minimal talking. So that's a perfect square, that's a perfect square. That adds up to twice the square root of our coefficients. So here we go. Okay, one more shortcut. This one's not nearly as complicated to figure out. We did some work with a plus b and a minus b in the last section. And now again, we're going from the polynomial to the factoring. So here's what you need to look for. If the first and last terms are perfect squares and there is no middle term, then the factorization will be a plus b, a minus b. I'm looking at page 513, number 3, problem A. V squared minus 100. Perfect square, perfect square. Our factorization will be v plus 10 v minus 10. Letter B is just as easy. It's two perfect squares. This one's being subtracted. It's a difference, I should say. So, s plus 4, s minus 4. Last but not least, the number 5 problem, which is on page 514, looks like this: 12t squared minus 48. There's no middle term, so you start to think optimistically, oh, it's a difference of squares, except that's not a perfect square, and, well, neither is that. But wait a minute, you are all clever, and you quickly realize that you can factor out a 12, and then, like magic, because it is a difference of two squares, now it's easy. It's just letter B. Not quite as beautiful, but notice before you do anything that you can factor out a 3. And then your problem looks quite a lot easier. Oh, I guess I have to do the rest still. Your next problems are on these 3 pages. These are actually leftovers from the last unit. These are 3 where you have to factor something out, factor a number out before you do your funky algebra factoring. And then these 2 sections are from this most recent section.